Hey everyone, we're going to jump right in and we're going to talk about probability. So probability is just the chance that something will occur. What is the probability of it raining? There might be a 30% chance. That would be the probability of it raining. So when we're looking at genetics, we're often looking at the probability of two different events occurring together. So the chance of two or more independent events occurring together is the product. Oh, whoa, that did not work what I wanted to do. The product of their chances occurring separately. So let's look at this cross where we have a big F, little f, and then a big F, little f. What is the chance of obtaining either a big F or a little f from a parent? So if you have a big F here and a little f, you're going to get one or the other. So to get the big F, you have a 1 out of 2 chance, and to get the little f, you have a 1 out of 2 chance. So the chance of a big F is 1/2 or 50%. The chance of the little f is 1/2 or 50%. So in this cross here, we're looking at to get a big F from here and a big F from here, you have a 1/2. I'm just going to draw it down here, okay, because this way you can see it better. So the chance of getting this big F is 1/2, and the chance of getting this big F is 1/2, right? To make a big F, big F. That should be a big F. There you go. So how we figure this out is we're going to multiply these fractions. When you multiply fractions, you multiply the denominator, and 2 times 2 is 4, and you multiply the numerator. 1 times 1 is 1, and that's where you get this 1/4, okay? So if you want to do the big F with a little f, again, you have 1/2 times, in this case it'd be 1/2 here, right? And again, you're going to get 1/4. To get this little f with this big F, you have a 1/2 probability here. And again, you're going to get 1/4, and then you can get little f 1/4 of the time. So that's using the law of probability and the product rule, or product rule of probability. So the sum rule of probability states that a chance of an event that can occur in more than one way is the sum of each individual chances. So if you have someone that is going, or that has a chance of having freckles, right? Freckles is dominant, and I'm going to show you again. I'm just going to draw that Punnett Square. What? I always find it weird when that happens. So I have a big F, little f, big F, little f, and remember, I'll put it up here, big F something equals freckles. The only way you get no freckles is to have 2 little f's. No freckles, okay? So you can have a big F here. You can have a big F, little f, and then you have a little f, right? So if you have a big F like this right there, you're going to have freckles. Big F, little f, you're going to have freckles. This big F, little f, you're going to have freckles, right? So you would have to add these 3 chances together, and you would get 3/4. So 75% chance or probability that you're going to have freckles, and only a 25% chance that you're not going to have freckles. So a test cross is a cross between an organism that has a dominant characteristic and then an organism that is homozygous recessive. So you cannot determine just by looking at someone or some organism if they are homozygous dominant, if they have the dominant trait, if they are homozygous dominant, or if they are heterozygous. So we use a test cross where we cross that organism with a homozygous recessive individual, and then the offspring tell us what we're going to have as our result. So we determine it by looking at their offspring, and if offspring are, or if any of the offspring are showing the recessive phenotype, then we know that the parent that has that dominant trait is heterozygous. Oh, it didn't underline. There we go. So let's look at what that looks like. So here we have a parent that is homozygous dominant with that recessive. And so we have the dominant organism here, the male over here, and we're crossing it with a female up here. And in this case, we're looking at freckles, but it can be any trait we care about, whatever. And so if we have a homozygous dominant individual, all of the offspring will be, or will carry that dominant trait. And in this case, they would be heterozygous. But if we have an individual that is heterozygous, still shows the dominance, now the offspring 50% of the time will be dominant. The other 50% of the time will show that recessive characteristic. And then we know that we have a heterozygous parent. I'm going to stop here and we'll get into 2 trait crosses in our next video. Bye.